Hello. Today I'm going to be going over why Tsoding's DBSCAN image segmentation implementation is a bit incorrect. So when we look at his implementation, he does this weird thing where he finds the neighbors in the color space from the pixels next to the current pixel. It's not usually done in DBSCAN implementations because when we go to the Wikipedia page, they do this range query, and this is DB. So the DB represents the database of points, and we find neighbors from the points in the database. We don't pick specific points from the database to find neighbors from. So when we fix that, we get this code over here, which I wrote in Python because I'm not as good as writing code in C. So first we load the image, we resize it, then we append all points and their indices in the image and also their color, right? So is define basically returns if a class label has been assigned to a pixel. So one is noise, so if one noise is not class here, so yeah, if 0 or 1, this will return false, otherwise it will return true. So this is the distance formula I'm using over here. So if you want to only cluster in RGB space, you would multiply 0 over here, which is the distance between in the x and y axis. And moving on, this is the neighbor finding function. So as you can see here that I find my neighbors over the entire points list, just like in the Wikipedia Wikipedia pseudocode. So I'm using my points database to find my neighbors. So when we run this is our result. Now an in-between implementation, so to say, between what Tsoding did and between the actual implementation of DBSCAN is to use the coordinates of each pixel in the cluster space, right? So pixels close to each other will be more likely to be clustered together than than pixels farther than each other, right? So this is using this distance function, we can get an image such as this. It takes a lot of time because it's Python, but we get something like this. So yeah, that's what I wanted to say. Thank you.